This is the remote imaging protocol, and it allowed dial-up bulletin board systems to show color bitmaps and vector graphics along with text in a user's terminal, even over a slow modem connection. Sound a lot like something else we use pretty much every single day? Well, this came first. And in a different timeline, it might have even won out over HTML. As the 1980s came to a close, dial-up bulletin boards were reaching the peak of their popularity. The internet hadn't yet found its way into the average home, and the first primitive web browsers were limited to Unix and the X Windows environments. If you were online in this point in history, you're sure to remember character graphics using ANSI or PETSCI. But before surfing the web became a household term, there emerged a competing technology in the form of the Remote Imaging Protocol, or RIP. RIP and its associated language RIPscrip were created by AST research alums Jeff Reeder, Jim Bergman, and Mark Hayton of Telegraphics Communications in 1992. Prior to this, the dial-up BBS experience was largely limited to plain text and character graphics. Entire subcultures sprung up around the creation of digital art using ANSI and PETSCI, and many of us have fond memories of those times. However, the future was right around the corner.
ANSI interfaces to online services, however common in the past, are quickly becoming obsolete. They are being replaced with elegant, high-quality graphical presentations. This was not possible until the advent of technologies like RIPscrip. A graphical online service is considerably easier to use. Simply click on what you want to do, and it happens. Cryptic commands and text-based menus are a thing of the past.
RIP was a significant leap forward for the humble dial-up BBS, offering full-screen color artwork, mouse-driven user interfaces, online games, sound, and more. But RIP wasn't the first technology to implement real-time vector images on a bulletin board. Instant Graphics and Sound, or IGS, was released by Larry Mears for the Atari ST as early as 1988, predating RIP by several years. However, by the time RIP did arrive in 1992, the ST was already in decline, and development of IGS had ceased in favor of greener PC pastures. Of course, by this point, the internet and the World Wide Web were poised to take off in a big way. While web browsers had already been available for a couple of years, support for displaying text and graphics in a single viewport wouldn't be seen until 1993. Even then, it wasn't until later that Mosaic and Netscape began supporting home platforms such as macOS and Windows. All this to say that at this pivotal moment in history, things were still very much up in the air and any future was possible. For their part, Telegraphics looked at the oncoming storm, dug in, and took their shot. Upon its introduction, most users would have dialed into RIP-enabled boards using Telegraphics' own software, RIPterm. While the client was provided free of charge to end users, the RIPscrip creation tools that were required by BBS operators were not. The software itself was pretty basic for a PC terminal of the day, supporting a built-in phone book, a variety of file transfer protocols, scrollback buffer, and a few other quality-of-life features. It did feel a bit slow and clunky if you were used to using other text-only programs, so I tended to use RIPterm only when I wanted to call a board and see their graphics. When connected to a RIP-enabled BBS, there were two separate viewports, one for graphics and another for the plain text and menu prompts. Sysops were able to define the viewport geometry to create their own custom graphical interfaces, incorporating the text area as a UI element. It was also common to relegate text prompts to a line or two at the bottom of the screen. Window attributes such as color, font size, and word wrapping could be controlled by the sysop as well. It might seem basic by today's standards, but RIP was a shot in the arm for dial-up boards who had been stuck using character graphics for over a decade, and adoption was speedy. The Searchlight BBS package was the first to have native support for RIP. However, the language was coded using plain 7-bit ASCII characters, and as such, could be implemented by just about any existing board, especially those with multi-language capabilities. Native RIP support would eventually be found in at least 16 packages, ranging from heavy-hitting commercial staples like PCBoard and Major BBS to popular freeware offerings like Renegade, which is what I ran. Bulletin boards weren't the only ones to get in on the graphics game, though. Commercial online services were already doing similar things, one example being Prodigy, which implemented their interface using an earlier standard called NAPLPS, the North American Presentation Level Protocol syntax. Remember that? It'll be on the test. This technology has a similar aesthetic to RIP, but was developed much earlier for use with television, interactive kiosks, and other proprietary information systems. By making RIP-term freely available and designing RIPscrip to be easily and widely supported, it was clear that Telegraphics was trying to capture as much market share as possible. Unlike NAPLPS, RIPscrip could be coded by hand and used without costly proprietary hosting solutions. Telegraphics even published their protocol specification for everyone to use. Of course, none of this was done for altruistic purposes. They simply wanted to become the industry standard in order to sell their closed-source development products. For a brief period in time, it seemed like Telegraphics might get their wish. The popularity of RIP climbed steadily, and the format eventually gained support in over a dozen different terminal emulators for DOS, Windows, OS/2, Mac, Amiga, and the Atari ST. I even supported RIP graphics on my own BBS, the 64th Dimension. I remember painstakingly laying out prepackaged icons to create custom menus for every area of the board. I was never talented enough to create my own vector artwork from scratch though, nor did I have access to the aforementioned commercial development tools. Speaking of which, this is RIP Paint, Telegraphics' own creation tool. While it was entirely possible to code RIPscript by hand in a text editor, this software made it much easier to see what you were doing in real time. It covers all the core functionality of the protocol and included a vector graphics editor, bitmap icon editor, configurable viewports, button wizard, and more. Another feature that RIP brought to the table was mouse support. It provided for interactive objects such as bitmap icons, text boxes, and rectangular fields to be defined anywhere on the screen. These would then link to other areas of the BBS or chain together commands to be executed without the need for a keyboard. Behind the scenes, a mouse click simply caused the terminal to send a pre-programmed string of text as if the user had typed it themselves. Simple, but effective. RIP provides a clipboard that data can be moved into or out of. Rudimentary animation can be accomplished with creative use of the clipboard or by chaining together a sequence of draw and erase commands. Another commonly used technique was to create multiple icons, one for each frame of animation, then replace them on the screen in quick succession. As time went on, creative artists found clever ways to stretch the limits of the format. We'll take a closer look at the art scene in a few minutes. Another use of the clipboard was to draw a vector graphic, then copy and paste it multiple times to other parts of the screen in order to reduce loading times. A useful optimization when dealing with lamers who were still dialing in with their 2400 BPS modems. A variety of vector drawing primitives were available to use, including single pixels, lines, rectangles, ovals, Bezier curves, and polygons. A variety of prepackaged pattern fills were also supplied to give your menus and graphics additional texture without the loading time penalties of unnecessarily complex drawing commands. Rudimentary PC speaker sound could also be embedded using a number of predefined special effects. Tones of arbitrary frequency and duration were also available, enabling a semblance of music to be played. It's also worth noting, get it? That RIPscript wasn't just limited to use on bulletin boards. The text-based documents could be viewed offline, shared via email, posted to forums and wide area relays such as FidoNet, or even used in presentations. Later versions even touted RIP as a solution for dating services, real estate agencies, and multimedia games. As you've already seen, This initial version of RIP uses 16-color EGA graphics at a resolution of 640 by 350 pixels. VGA and Super VGA were already ubiquitous by this time, so a common complaint was that the technology already looked a little dated upon its release. The underlying rendering engine was powered by BGI, the Borland Graphics Interface. This was a commonly used DOS library that was bundled with the company's compilers and provided basic graphics functions, 11 integrated fonts, and support for custom bitmap icon files. RIPscrip itself is a simple page description language, similar to Adobe's PostScript. A series of ASCII text instructions describe the vectors to draw. Each line of code begins with an exclamation point, and every command is prefixed by a pipe character. This is followed by a single letter indicating the desired command, along with any additional parameters. Multiple commands can be stacked in a single line, and individual lines of code can be intermixed with plain text and ANSI character graphics. RIPscrip commands were kept intentionally terse in order to minimize the number of characters transmitted. This meant RIP worked well even at slow dial-up speeds, and a complex picture could easily fit in a few kilobytes. The downside to this was that the language was difficult for a human to parse, a trade-off Telegraphics was willing to make in the name of performance. RIP's vectors could be supplemented with predefined bitmap images in the form of icon files. These could be created and customized for each individual BBS, then pre-positioned on the user's computer. In this way, they wouldn't need to be downloaded each time they were displayed, similar to how your browser's cache works. Unlike your browser, however, the user was required to manually download and extract the icon library on their first call, and again whenever the sysop updated their icon pack. To save even more bandwidth, numeric values were encoded in base 36, from 0 to 9, and capital A to Z. This allows large numbers to be represented in fewer bytes, at the sacrifice of making RIPscrip even more obtuse to read and write without the aid of software. As an example, if you wanted to place text at a specific position, you'd encode it like this, where 0Z is 35 pixels to the right, and 1Z is 71 pixels down from the upper left corner of the screen. While Telegraphics did publish the protocol specification, their software was still closed source. They were in business after all, and their revenue came from selling their expensive development software. With the widespread adoption of RIP across the BBS ecosystem, it should come as no surprise that a non-trivial amount of third-party software started to pop up, including freeware viewers, editors, graphics and icon packs, conversion tools, and BBS add-ons. Because RIP's internal algorithms were proprietary, third-party software was unable to fully replicate the way Telegraphics implemented some things, such as Bezier curves. This led to rendering glitches such as flood fills that would leak out and paint over the entire screen. Still, for a teenage sysop like yours truly who couldn't afford RIP Paint's $200 price tag, it was either that or piracy. And I would never do anything like that. What would be the point of having these fancy new graphical capabilities if there weren't some form of entertainment that took advantage of them? Doorway games were already a staple of the BBS experience, so it was only natural that some existing titles would get updated to include RIP support. Legend of the Red Dragon already had nice ANSI artwork for each area of the game, but the inclusion of RIP graphics made it all the more immersive. Just like with menu icons, the game scenes relied heavily on bitmap graphics that were provided as an initial one-time download. This way, the visuals could be displayed almost instantly and not degrade the experience by slowing down the pace of the game. There were also quite a few games made specifically for RIP, one such example being this Tetris clone here. The gameplay is responsive, the graphics are good, and it even makes use of some of RIP's built-in sound effects. The big draw to playing such a game through a BBS instead of locally would be to get your name in the high score list for all to see and to challenge. Provided with a new medium, artists always seem to find a way to express themselves. Some of the big-name groups, such as ANSI Creators in Demand, or ACID, also got involved with creating RIP graphics. Similar to how they made humble character-based pictures come alive, these talented artists pushed EGA 16 colors and low resolutions to the limit and were able to produce some incredibly striking imagery. While it's not so surprising, something that might be is a sort of renaissance that RIP has enjoyed in the last few years. Not only is new artwork being created, but there's even a Facebook group of folks who are dedicated to sharing these images, maintaining telnet boards, and even creating new software to use with modern operating systems. For me, there's a certain charm to watching these images slowly render, one vector at a time. In this way, you get to see each and every brushstroke the artist originally made during the creation of their work. This is something that's been lost in today's world of instant gratification and infinite scrollers. I didn't even speed this clip up like some of the others, so you can enjoy it the way it might have originally been experienced at 9600 bps. And for completeness' sake, here's an example of that wonderful PC speaker music I mentioned earlier. Ah, lovely.
RIPterm Professional 2.0 is far more than just a hot new computer program. It shifts traffic on the information superhighway into warp speed. It's a powerful tool that fundamentally changes the way people use computer networks to work, play, and communicate. With our technology's power to uplift human potential, we believe RIPscrip 2.0 will convert the tons of modems into the bells of liberty for people everywhere.
RIP 2.0 was released to little fanfare in January 1995 after 2 years in development. This update brought with it many new features, including bitmap image support, TrueType fonts, and higher resolutions with millions of colors. Unfortunately for telegraphics, the big delay in bringing this new version to market likely hurt their overall chances of success. In the intervening years, the World Wide Web and its associated technologies had taken huge leaps forward. To make matters worse, the new version of RIPterm was no longer free to use. These and other factors resulted in a poor adoption rate of the new software. Even to this day, version 1.54 remains the gold standard that you'll find used on telnet boards and in the majority of artwork out there.
Nobody can deny that the World Wide Web has taken the industry by storm. The major problems with the web, though, are how difficult it can be to use. Potentially frustrating issues about IP addresses, domain names, name servers, and gateway addresses have caused many users to simply give up, leaving a sour taste in their mouth about the internet. What is needed is an easy way to get those users on the web without the hassles of getting their internet connection working.
As adoption of the internet and the World Wide Web continued at a relentless pace, things were looking less rosy for dial-up bulletin boards and RIP technology. Telegraphics responded by pivoting to make their product line internet capable with the introduction of RIP Web. This server-side technology allowed users to access the World Wide Web with their existing terminal software and without the need for a TCP/IP stack and a SLIP or PPP connection. A translation layer on the backend retrieved HTML pages and graphics, then converted them on the fly to RIP, which would then be displayed in the user's terminal. The company was banking on making the internet experience simpler for novice users by obviating the need to have internet access or a web browser at all.
Unlike current web technology, where doing basic graphics is difficult or nearly impossible, RIPscrip offers the ability to show state-of-the-art graphics on the web. RIPscrip is typically smaller than similar HTML documents. In some cases, the size differences are staggering. This could be the exact thing that the internet needs to stop choking up the network and allowing information to flow quickly through the system.
Even at this late stage, Telegraphics held on to hope. As part of a multi-point strategy that included RipWeb, they planned to develop plugins for existing web browsers and even release their own standalone browser as part of their version 3.0 offering that would enable the use of RIP graphics on the web alongside HTML. Their rationale? The format was smaller and faster than HTML and static image files. It's my impression that the company had already seen the writing on the wall, but they still held on to hope that RIP could become the graphic standard for the web. The 3.0 specification even had some ambitious goals, including full motion video and streaming audio. Of course, we already know how the story ends. Users flocked to the internet in droves. Telegraphics, unable to find outside funding, began financing their expenses from personal funds and credit cards. Unable to compete, it would be the Silicon Valley tech giants like Adobe that paved the way for dynamic graphics and animation on the web with their wildly popular Flash plugin. Within a few years, the decline of the dial-up BBS was inevitable. Most users of the internet had never even heard of Telegraphics, and development of RIP came to an end with version 3.0 never seeing completion. The company held on until the turn of the millennium, continuing to support their ProBoard and Searchlight BBS products until shutting their doors in late 2000. While short-lived, the remote imaging protocol had its moment in the sun, but like so many other nascent technologies, it never came to realize its full potential. And that is the end of the story. I hope you enjoyed this bit. Thank you so much for watching, and see you next time on Retro Bits.